Hello everybody, so today I will be doing tutorial chapter 5. So we have question number 1, a magnetic field of 4.5 Tesla. So remember I've mentioned that if you don't know what is magnetic field, just look at the unit. So this is Tesla, meaning it can only be B lah, which is the magnetic field. So it passes through a circular coil of radius 5 centimeter and 100 turns. So this is N. Determine the magnetic flux linkage associated with the coil in the conditions of magnetic field. Passes perpendicular to the coil. So this one is basically just the theta is changing lah. The value of theta is changing. So we have a magnetic field being perpendicular to the coil. So if we were to draw that, let's just assume that our magnetic field is going to this direction here. Let me just do this, and then okay, I've turned on the microphone. Okay, so we have this. Now this is basically the magnetic field, and then the plane of the coil is now perpendicular to the magnetic field. So ini adalah our punya, this is our circular coil, so it should be circular. Kita buat gitu. So we know that the formula untuk magnetic flux linkage is uppercase phi. So this is basically N lowercase phi. So we know that phi here is BA cos theta, where the theta here is the angle between B and A. So remember, the angle saja yang berbeza. I mean the formula, all of the formulas are different, but then the angle is also different. The definition of angle depends on the type of the types lah, whether it is straight conductor, coil ka, apa macam tu lah. Okay, so angle tu kamu kena ingat. So this is uppercase phi. So now we know that vector A, which is the area, is gonna be normal to the surface. Okay, so it's gonna be normal to the surface. So this is A. Sekarang ni kita tengok the angle between B and A is 0 degree because they are both in parallel. So substitute di sini uppercase phi, number of turns is 100, and then we have B, which is 4.5, area is basically just pi r square, and we know that r is 5 centimeters, so that is 0.05. 1, 2, yeah, 0.05. R is pi r square times with theta, which is cos 0 degree. So you will get the magnetic flux linkage to be equal to 3.53 Weber. Okay. All right. Next, the magnetic field is parallel to the coil. So again, we have this magnetic field here. Okay, so sekarang ni kita punya coil sekarang ni dia parallel to the magnetic field. Biarlah dia tulis rectangle lah. Okay, so ini adalah circular coil kita, and then remember that the vector A will always be perpendicular to the surface, ataupun kalau kita tahu this is normal to the surface lah, panggilan yang lain. So this is vector A. Now the angle between these two is 90 degree kan? So this is 90 degree. So basically if we do it this way again, cos 90 degree will give us 0 Weber. Okay, so cos 90 is equal to 0 lah. Okay, next dia cakap it passes at an angle of 30 degree with the plane of the coil. So the plane of the coil, the magnetic field passes at an angle of 30 degree. So sekarang ni yang berubah adalah, I'm just gonna assume the plane of the coil is this one, and then the magnetic field is at a 30 degree angle. Okay, so ini adalah magnetic field ya. Kan? Pass it at angle of 30 degree. Yalah. Okay, so basically dia punya angle here is 30 degree. Okay, so sekarang ni we know that a vector A is perpendicular to the surface ataupun normal to the surface. So the angle that we want is actually the angle here. So this is our theta. Alright, this is B. Okay, so ini adalah vector A. So how do we calculate that? We know that this is kejap yalah, okay. Alright, so we know that this is 90 degrees. So basically this would also be 30 degree based on our knowledge in maths. So theta is gonna be equal to 90 minus 30, which is equal to 60 degree. So our value of theta is gonna be 60 degree, and just proceed with the calculation. N phi, so NBA cos theta. So just substitute lah 104.5 pi r square cos 60 degree. So kamu akan dapat the magnetic flux linkage to be equal to 1.77 Weber. Okay, so ini adalah solution for question number 1.